Good day to my beloved madam. I'm Choo.
I'm Dennis.
I'm Adam.
I'm Aizzad.
So today we're going to present about our determined map.
The properties of limit, there are 7 properties. So the first one is if lim x approaches a, c, it becomes c. And the second one will be lim x approaches a, x, then it will be equals to a. So the third one is if lim x approaches a, n to the power of, x to the power of n, so it becomes of a to the power of n2. So the fourth property will be if lim x approaches a, c, fx, you can take out the c out, so it becomes of c lim f approaches a, fx. Okay, and then the next one, lim x approaches a, fx plus gx. Okay, so you can actually separate it out, so it becomes lim x approaches a, fx plus or minus lim x approaches a, gx. So times and divide is also same, you can separate it out. So if times, if lim x approaches a, gx times gx, so it becomes lim limit x approaches a, fx times lim x approaches a, gx. So fraction is also same, so you can just actually separate it out. It becomes of lim x approaches a, fx and divide by lim x approaches a, gx.
Let's take a look at the methods for limits. So method 1 would be subbing the value of a into x directly. So for example, let's say when we have limit x approaching to 3, 5x. So we could solve this equation by substituting 3 directly into x. So it would be 5 times 3. So the limit of this function would be 50. Method 2 would be factorization, because sometimes when we sub in the value of a directly, we will get an undefined value such as 0 over 0. So the only way we could solve questions for limits would be by factorization or by multiplication of conjugate. So let's say if we have x cubed minus 8 over x powered by 2 minus 4. So we could factorize this equation first, because when we sub in let's say when limit of x approaches to 2, if we directly sub in 2 into x, we will get an undefined value which is 0 over 0. So we do not want this. So the only thing we can do here is by factorizing x powered by 3 minus 8 and also x powered by 2 minus 4. So when we factorize them, it will be x minus 2 x squared plus 2x plus 4 and x plus 2 x minus 2. So here we could cut x minus 2. We will only left x squared plus 2x minus 4 over x plus 2. So here we can directly sub in the value of 2. And lastly, we will get 3. So the limit of fx when x approaches to 2 would be 3. Sometimes when we have an equation that cannot be factorized, the only way we could solve it is by multiplying the conjugate. So let's say if we have squared x minus 1 over x minus 1. So here, when the limit of x approaches to 1, if we directly sub in 1, we will get an undefined value which is 0 over 0. So the only way we could solve this is by multiplying the conjugate, which is sub x plus 1 over sub x plus 1. And then when we multiply them together, we will have x minus 1 over x minus 1 times with sub x plus 1. So when we sub in the value of 1, cancel this, and we will get 1 over sub x plus 1. So when we sub in the value of 1 into x, we'll get 1 over 2. So the limit when x approaches to 1, fx would be 1 over 2.
Okay, so now I'm going to explain the method 4, which is one-side limits. This type of method is used to find the limits of x approaching a values when there's only a one-side limit. For example, in a graph of like this, when x approaching 2, okay, from the left the values of y is 1, while when x approaching the values of 2 from the right is the y is equal to 2. This condition is called as one-sided limits. So method 4 is help us to find the one-sided limits, like for example limit x approaching 2 minus from the left fx is 1. So this is methods 4. Now I'm going to explain methods 5. Methods 5 are more or less like method 4, but for method 5 we're going to find the test the existence of limits by find the limits of x approaching a values from the left and also from the right. This is important so that we can get the same values while x approaching a from left and from right. If the values of x from left and from right are the same, that means the limits x approaching a and fx exists. For example, limit x approaching 1 minus and also limit x approaching 1 plus for the piecewise function hash x equal to 4 minus x squared for x smaller or equal to 1, and also 2 plus x squared for x bigger than 1. Okay, so from the left we can get at 4 minus 1 squared equal to 3, while for the limit x approaching 1 from the right side is 2 plus 1 squared, so it's 3. So both of this equal means that the limit of x approaching 1 fx exists. Now we are going to explain about the method 6, which is the infinite limits. This method is also help us to find the horizontal asymptotes of a function. Okay, so for infinite limits, it's a condition like this lah. And then when the values of x is approaching 0, that means the values of the denominator is smaller and smaller. Or as we know, when the values of denominator is keeping decreasing, that means the values of fx will be approaching infinity or negative infinity. Therefore, the values of y will continually increasing or decreasing towards the infinity, and thus this causes the values of y does not touch the line of x approaching, like for example 0. Okay, and then for limits at infinity, the values of x is approaching infinity. Approaching infinity, either positive or negative. And in this condition, x is in the denominator. Okay, so as we know, when the infinity become the denominator, so anything above infinity will become just 0. So for method 7, we can conclude that as limit approaching infinity 1 over x is equal to 0. Okay, finally we are going to talk about finite limits also, but we are going to use rationalizing method to find values of fx when x is approaching infinity. For example, limit x infinity x plus 3 x plus 2. The up will become infinity, the down will become infinity, right? So we can, what method we can use, we can divide both denominator and numerator by x, and then we'll get the answer equal to 1. We can also use the conjugate methods like Adam talked about just now in order to rationalize the infinity inside the x. This is important to help us to find the limits of fx and also x in order to find the at point 2 asymptotes.
So we continue with asymptote. So basically there are two types of asymptote, that is vertical and horizontal. So for the vertical asymptote, as the limit of x approaches a from the right, the asymptote can be positive or negative infinity. And for the limit x approaches a from the left, the vertical asymptote can be positive or negative infinity. And for the next one is the horizontal asymptote. The limit of x approaches positive infinity, the horizontal asymptote is equal to b, and is the limit of x approaches negative infinity, the horizontal asymptote equal to b. Continue with the continuity. So basically the definition of continuity is a function that can be graphed throughout its domain with one continuous motion of the pen. There are two types of continuity, that is continuous and discontinuous. And as you can see from the graph, continuous is one connected line. The discontinuous is two separate lines. For the continuity test, there are three conditions for it to happen. So the first one is when we sub the value of c into the function and the function is defined, and it means that it has value and it is not undefined. And then for the next one is when the limit of x approaches c and the fx exists. It also means the same thing, that is, it has the value. We can conclude that the limit of x approaching c of the function is equal to the function when the c is sub into it, the interior point. So basically means that it is a two-sided function, limits, and as we can see that interior point is in between a point, so it is continuous, as you can see. And then last but not least is the endpoint, and we can call it single-sided or one-sided limit. As the limit of x approaches a from the right, so the function will actually equal to the function when it is sub with any value of a from the right. And same goes to the limit of when the x approaches a from the left, so it will equal to the function when it is sub with any value from the left, so it is not equal.